Hey everyone, today I want to talk about something that's near and dear to my heart, and it is the fact that 1-inch pleated filters, they are by large the silent killer of HVAC systems. Not kidding around, something that's a real problem, it's real, it's out there, something that keeps me awake at night. More than anything else, there's me laying in bed, can't go to sleep because I'm thinking about airflow restriction. So you're probably thinking, Nolan, you're being ridiculous. Like, who cares? Well, I'll tell you what, it's a pretty big deal. I've tried to preach before that if you check static pressure drops across 1-inch filter, you're going to see, 0.3, 0.4 inches water column pressure drops. And, I'd say, all the 1-inch pleated filters out there, you're pretty much going to see it. I mean, it's very rare that I've seen one that doesn't have a pressure drop like that. So got a little chart here. This just shows some common filters that a customer might buy at a big box store, like a Target or a Walmart or something like that. Places where people are going to go and buy filters, even Home Depot. I took out some of the common brand names just to, not call anybody out, but I mean, it's pretty much across the board, any 1-inch pleated filter. So you can kind of see here, if we look at some common airflows like 1200 or 1600 CFM, at 1200 CFM, this is a 20 by 30 by 1 filter, by the way. So I don't know about you guys, but I don't commonly see 20 by 30 by 1. It's pretty much like 16 by 25 by 1, 20 by 25 by 1, and then all the other weird sizes. But looking at a 20 by 30 by 1 at 1200 CFM of airflow, your drop across it is rated clean anywhere from 0.18 to 0.23. Now at 1600 CFM, we're looking anywhere from 0.26 to 0.34 clean. And those are pretty common airflows. Those are huge pressure drops. And this is on a 20 by 30 by 1 filter. So if customer has a 16 by 25 by 1 in there or a 20 by 25 by 1 in there, I mean, who knows? So let's just take a look at a system just to, kind of get an idea of what we're actually talking about, what it looks like on a system. So we'll throw in some numbers in here. Let's say we're checking static pressure. On our return duct, we'll say we're reading 0.09 inches water column at 1600 CFM. We'll throw in that 20 by 30 by 1 filter with a 0.26 water column pressure drop. So I just use the best case example on the filters listed at 1600 CFM. So across that, we have 0.35 inches water column at 1600 on the inlet to the blower. And then, we just take some common readings on the supply side. Let's say before the coil, we're at 0.35. We have a drop across the coil, 0.24, and its supply is 0.11. So the supply side, I mean, there's really nothing that the filter is affecting, but beforehand, that 0.35 is really what the filter is affecting. So in that case, I mean, we're at 0.7 inches water column total external static pressure with a 20 by 30 by 1 pleated filter at 1600 CFM. So imagine if it was, 20 by 25 by 1, or if the airflow was higher, yeah, make it stop. Like, I don't want to think about that. That'll definitely keep me awake at night. So again, why is this so important? Why should I care that the customer is using these 1-inch pleated filters? Well, if you really want to provide a great service to your customer, you should know that, having these big pressure drops, restricting airflow, it's causing things like, if they have an ECM blower, it's using way more power. Your customer's just throwing money out the window on their blower motor, essentially. Also, if it's bad enough, those blower motors can fail, after 5 years, after 3 years, who knows? But, then the customer is going to be inconvenienced. They're going to be spending a lot of money on replacing a motor when maybe it could have been prevented with proper design. If you have a constant speed motor, a PSE motor, you're just not going to be moving enough air through the system. And then you can get it where it's overheating or it's freezing up, nuisance trips on lockouts, things like that. Also, their comfort's being affected. I mean, if you don't have the right airflow, you're going to have hot and cold spots in the house. You know, also we're reducing heating and cooling capacity on the equipment. So, you know, we're going to have long run times. We're going to rack up that electric bill trying to heat or cool the house on, you know, a really cold or really hot day. And, you know, static pressure is bad enough if you have a big enough pressure drop and the blower is trying to run. If you have an ECM ramping up, you know, it's going to be really loud for the customer. And, you know, as you guys know, noise complaints can, you know, really be a big deal for customers. So what can we do to help the cause? You know, how can we prevent this nightmare of big pressure drops from happening? Well, if you go into a customer's house and you see they're using a 1-inch pleated filter, you know, check static pressure. Even at the very least, just check the drop across the filter. You know, I guarantee that if they're using a 1-inch pleated filter, you're going to see that big pressure drop. You know, you're going to see that there's a visible issue there. And that you can actually show your customer. You can take it to them and say, hey, you know, you're using these filters. They're great for filtering out the air, removing allergens, but you know what they don't tell you is it restricts airflow and it's going to cause long-term effects on your heating and cooling equipment. So then you can just inform their options. You know, not every customer is going to want to upgrade to a high efficiency air cleaner. You know, some of them might just want to go ahead and go with, have pictured here, one of the True Blue fiberglass filters. And that's fine. I mean, that's going to save them in the long run as far as things overheating and things like that. You know, it's good to at least let them know that if they're using those filters, they're going to have more dust, allergens, things like that getting into the equipment. So as far as from a comfort standpoint, their air is not going to be quite as clean as it could be. And then, you know, their blower wheels, their evaporator coils, they can get dirty. They lose efficiency that way. So my biggest recommendation is to talk about, you know, Aprilaire filters. You know, it's pretty reasonably priced for the customer. Usually it includes some return ductwork modification, which is always nice. It helps with pressure drops and things like that. And then if we look on a chart here from Aprilaire, this breaks down their pressure drops. And so if we look here, you know, in sort of like the 1200 CFM range, if you have a 210 filter, your pressure drop's 0.11. If you had a 410, you're looking at 0.12. If you have 1600 CFM, you're looking at 0.16 or 0.19. So once you get into those higher airflows, the Aprilaire 510 filter actually really helps cut down on that pressure drop, which can be huge in some situations, especially with the high efficiency equipment that we're getting into now, where, you know, static pressure is so critical. If our static pressure gets really high on the system, it can shut down blowers, it can cause blowers to go bad. Like, we really need to start paying attention to this stuff. So there's some numbers there on it. So let's just put some of that to use in our previous example. You know, we have our same return duct, 0.09. Let's throw a 210 filter in there from Aprilaire. And now we've brought that blower inlet static pressure down to 0.25. So 0.25 on the inlet of the blower, 0.35 on the outlet. All of a sudden we're at 0.6 total external static. So we're getting better. You know, 0.6 I could live with. You know, obviously we always want to shoot for 0.5, and let's say we want to do that. We really want to try to get to that 0.5 total external static pressure. In our next example, we'll use the same demonstration, but we'll throw a 510 Aprilaire filter in there. So here we swap it out. We have 0.07 inches water column drop across it. Now all of a sudden our blower inlet static pressure is 0.16. Add on that 0.35, and hey, we're at 0.51 inches water column, which is pretty much near perfection. I mean, you know, I'm super happy with that. So really, in conclusion, I mean, it comes down to the ductwork that's in homes. It was not designed for 1-inch pleated filters. It was not designed for that pressure drop. So, you know, if you wanted to use 1-inch pleated filters, what you could do is you could just, you know, take 2 of them, you know, if you can come up with sort of like a V formation or something like that, you could put 2 of them in there, and then you're essentially dividing the airflow into 2 filters instead of just the one. So, I mean, that always is an option for the customer. But those filters are still pretty expensive. So if you're buying 2 of those and replacing them every 3 months, that's going to rack up on costs. Versus, you know, one time a year with an Aprilaire filter, or obviously the True Blue filters, the fiberglass are going to be, you know, very cheap. So existing ductwork, 1-inch pleated filters, you know, that's just not what it was designed for. Really just do the right thing for your customers. I mean, I know for a long time, checking static pressure, like it wasn't an industry-wide thing that everybody's paying attention to, but you know, it's really something if we want to do this job as well as we can, if we want to do the right thing for our customers and, you know, have their systems working as well as they can, as efficiently as they can, saving customers energy. I mean, it's really time to start, you know, looking at this stuff and making sure we're doing the right thing for the customer. So hope you guys got some insight on this as far as, you know, why we really need to start paying attention to 1-inch pleated filters and the pressure drop and everything. Appreciate you guys checking it out. Thank you.